Good morning, everyone. Wi-Fi is a technology that we're all familiar with. It is simply the data transmission over radio waves. Now, for our project, it is LiFi, the data transmission over light waves. For our project, we wanted to apply this kind of new and upcoming research into the industry. Our objectives were to look at an ambient light data link in which we could have a one-to-many communication. It should be able to handle parallel networks separated by color and able to function despite obstructions moving through space, as in waving your hand in front of the light link, and then it should still be able to work once you remove it. If we look at the diagram here, our area of focus is specifically that optical network. We are in conjunction with another team, but we are Team 614. My name is Victor Nguyen, the team lead.
My name is Sean Gupta, the software lead.
My name is Parash, and I'm the mechanical designer.
I'm Gary McQuiston, the communications protocol designer.
And I'm Ali Kojaturk, hardware lead.
Now, for our system, we set up the small diagram on the bottom left. This is what we have that's working. It is a 1 meter distance, and it's able to send data from one side to the other, being able to transmit and receive. Our performance metrics was to make sure that we have a maximum distance of 1 meter with a field of view of 60 degrees, have a data rate comparable to 10 base T, and a packet loss no greater than 5% factoring in obstructions. Due to time constraints and budgeting, we were able to meet some of these objectives and performance metrics with a good distance and being able to send data across effectively. Packet loss could be questionable as it goes around 40%, but the data rate is a challenge, especially since it was the difficulty of finding a proper LED photodiode pair with appropriate switching speeds to achieve the data rate. Field of view was very difficult for us as well. We weren't able to achieve 60 degrees, but we were able to achieve 5 degrees field of view. The data loss was not able to meet that 5%, but we were able to send data across effectively over this data link. This concludes our presentation. Are there any questions?
So how are you actually sending? Are you doing some sort of PWM or flickering, or what's the actual data sending method?
Ali?
We are modulating the power of the LEDs. However, I believe the exact details of that might be covered by our NDA.
Fair enough. Was there any concern on the modulation of the LED power and flickering causing some disturbance to those in the area visually?
The modulation occurs at such a high data rate that you cannot see its flicker. The light just looks like it's constantly on.
So your 5% packet loss looks like it's pretty high. Yeah, here, even the 5% is pretty high. So what are you gonna do about that?
So for that packet loss, we are trying to look at other ways to improve that. We don't have many alternatives to test right now. We were planning on trying to get a more controlled environment due to the lights above us being able to affect that data transmission over the link. We were looking into like covering up our system with blankets and trying to test that.
Does that solve a real world situation then? You know, it seems like it's an artificial constraint.
Yes, that's a very good point. We were also looking into other LED and photodiode pairs to see if maybe more power could help or different lenses. Ali, would you have any other?
Okay, so typically increasing the power is not something that you do if you understand Shannon's laws in order to improve your packet rate.
So under our current testing, we weren't
That
able to...
concerns me.
We weren't able to test the system nearly as much as we wanted to in terms of actual packet loss. We were, however, able to get the packet loss to around 3% by adjusting the packet interval, but we consider that a somewhat controlled circumstance. As for the dark environment, this was originally designed to be implemented in a server room, or inside of a server rack, which is, well, not particularly very dark, is darker than a room like this. So it would be worth our time, if we had the time, to test in a darker environment.
Right.
All right, let's thank the team.